All right, so first lab of the year is titled Water Investigation Lab. It fits into our title of our unit, which is called What is Science? And we're taking a look at basically how we use science to learn and study different things. And the question that was posed to start with is whether or not you thought that adding salt to water would increase the boiling point. We gave an example of making macaroni and cheese, and whether or not some people use salt to speed up the process of cooking, and some of you did, and some of you said, no, we don't do that. And so we thought it would be a good starting point to look at whether or not it is worthwhile to use. And so let's take a look at the lab that we did. All right, so to start with, it asks you to take a glass, either a plastic glass or the beaker, and to fill it up with water. You could have filled it up to whatever amount of water that you wanted. And it asked you to think about if you were to take this metal screen that is right in here, what would end up happening for you? Would it float? Would it sink? Why do you think that this is the case? What will happen? And then to eventually test it. And so you made your hypotheses and you put them onto your whiteboard, and then you went ahead and tested it. And as you can see from the class example, that the metal screen is going to float. And so the reason for this, though, is because of the fact that it is less dense, but also because of the fact that the water molecules are holding this tight at the surface, and we call that surface tension. So at the very top of water, basically the alignment of the particles, water has different hydrogen and oxygen molecules, but basically the particles are real close together. That creates this surface tension. And so obviously the further down you go, they're a little bit more spread out. But at the very surface, that's what that looks like. It's a little bit closer together. And because of that, some types of organisms are able to walk on water, like water striders, but also objects that are less dense than that are able to float at the surface. And so what we discovered is the fact that water has surface tension, and at the very surface, it's able to hold up the screen. The next thing that you needed to do was to take a penny and to place it right in the center of the metal screen and to see what happens. And so when you did that, you probably discovered that it sunk. And so down went the metal screen and the penny. But something interesting happened. The metal screen did not come back up. And the reason for this is because both the penny and the metal screen had broken the surface tension of the water, but also because of the fact that that screen had holes in it, it would not allow for the water to push it back up. And so because of the fact that there were holes in the screen, it allowed for it to stay down at the bottom. So once the surface tension was broken, it was able to go towards the bottom. So main concept there, water has surface tension, and it's able to get down to the bottom when the penny was added. All right, the next thing you needed to do then was we wanted to get into the main part of the lab. We wanted to look and see what actually happens. By adding salt, does it increase the boiling point? Does not adding the salt increase the boiling point? Which has a higher boiling point? And so the way we set this up was we took a beaker and we filled it up with water, and we put it onto our hot plate. So this was our hot plate that we put, and most of you set the amount to 10. And so on the hot plate it went. You had a thermometer, and we talked about you don't want to put the thermometer all the way down at the bottom of the beaker. The main reason why is because this hot plate is giving off heat, and we don't want to register what the temperature of this is, but rather what the water is. So my suggestion was the fact that you put it down, touch the bottom, come off maybe a couple of centimeters, and then also there is steam that's being released here. You want to make sure that you tilt the thermometer because of the fact that you want to try not to get as much of the direct steam on there where it can actually burn your hand. And so most of you discovered that this type of boiling occurred somewhere between your ranges were a little bit about 90 all the way up to 100 degrees Celsius. Now, what technically should have happened is it should have been right at or around 100 degrees Celsius. Make sure we're measuring in Celsius as well. 100 degrees is equal to 212 degrees Fahrenheit. Okay, these are two important numbers that you want to make sure you get used to working with. But it should have been close to 100 degrees Celsius. Sometimes it'll be a little bit above 100 degrees. It's because of the fact that we don't have perfectly distilled or purified water. We use the water that comes through our school, where it has some different types of nutrients that are in there. So keep that in mind. But if you are on the low end, make sure that you keep the thermometer on there. Make sure that it's fully boiling. You'll know it's boiling because of the fact that you'll see lots and lots of bubbles that are going from the bottom to the surface. And make sure that you're reading all the way across on the thermometer. Okay, so that was the first thing that you had to do, because this was our baseline data. We needed to know without salt what the temperature was. The next thing you needed to do was to take a spoonful of salt and add it to the beaker. And when you did this, it probably increased the temperature somewhere in the neighborhood of 92 degrees Celsius up to maybe 102 degrees Celsius. And so you see that there was definitely, this is for the first spoonful, definitely an increase. And then when you added the second spoonful, it probably went up somewhere around 2 more degrees. So now maybe it was up to 104 degrees Celsius for the second spoonful. And obviously these are rough numbers. It depends on how much you added to your spoon. And then maybe the last one went up maybe just another degree up to maybe 105 degrees Celsius for the third spoon. The whole idea is that what we discovered is the fact that the salt, by adding salt to our beaker, it does increase the boiling point. It gets to a much higher temperature in order for it to boil, which means that we can speed up our reaction if you want to get your noodles to be more tender faster. If by adding salt you can increase the temperature and maybe speed up the reaction as well. We did not account for how long it took for the water to boil, and we did not account for how long it took the water to boil with salt. That's another type of experiment that you could run and test as well. But I do have a question that I'm going to pose here in a second. This was all through heating, okay, and you'll see this on the Google form that is right below where this video is. But I do have a question as to what happens if we do the opposite. So we used heating as our method, our form here. What do you think happens if we were to freeze water? What temperature do you think it would be? And then also, what about adding salt to water? Would it speed up the reaction of how long the ice would take to develop, or would it actually take longer for the ice to develop? And so I want you to think about that, because here we used the idea, we heat it up, we add salt to it, it obviously was able to create a higher temperature. But what if we did the inverse? What if we did the opposite and we were to actually take water and get ready to put it into the freezer and we added salt to it? Would it take longer for the ice to develop? Would it get colder through that process? And so I want you to think about that and respond. Also below the video, you're going to see that there is a couple questions that are a reflection. They're basically an opportunity for you to think back to what you learned, what you didn't understand about the lab. All of these are going to be without your name. Even though I'm recording your name, no other classmates will see what you respond with. This is only coming to me. And what I use it for is when we go over what happened in the lab, any of the questions that weren't addressed, I will address them through that without ever releasing your name. So it helps me to understand what sorts of things that you didn't understand without you having to feel like you need to share it in front of the class. So take a minute after you've watched this and respond to the questions, and I will see you very soon.